In example 3b, we need to compute the secant of the cotangent inverse of negative 15 over 8. Okay, so let's again talk about what we have here. Order of operations, we are going to start inside the parentheses. So you're basically computing the cotangent inverse of a quantity. So the way cotangent inverse works, you're going to plug in a number. This is going to return some angle theta, and then you need to take the secant of that angle. Okay, so ultimately your answer is going to be a number, not an angle. Okay, keep that in mind. Okay, we can again start off with the inside the parentheses. We're looking at cotangent inverse, so we need information about it. We need the domain and the range. Okay, so if we go dig it up, domain for both inverse tangent and inverse cotangent, that's all real numbers. Okay, and then if we go and grab the range for cotangent inverse, it's going to be 0 to pi. Okay, not including the endpoints. Okay, so this is the type of angle that needs to be returned, an angle between 0 and pi. Okay, so when we look at this, okay, and we're trying to translate the interior here, so cotangent inverse of negative 15 over 8. This is the angle between 0 and pi whose cotangent is negative 15 over 8. Okay, so when you jump to the unit circle and you're looking between 0 and pi for this particular angle, okay, so that corresponds to the top half of the unit circle. Okay, when you look around, cotangent is the x-coordinate divided by the y-coordinate. If you imagine doing this in your head, looking at the various angles on the unit circle and their corresponding xy values, when you do this, none of these guys are going to produce a number or a cotangent of this value, okay, which is negative 15 over 8. Nobody's going to give you that, okay? So again, you have to wonder, you know, is this even defined? Okay, well, look at the number we're plugging in. We're plugging in negative 15 over 8. That's a valid input because the domain of cotangent inverse is all real numbers. You can plug in any number that you want. Okay, so the conclusion here is that yes, it's possible to calculate this value, but you can't do it from the unit circle itself, okay, because it's some other angle that is not emphasized on the unit circle, okay. All right, so we're going to do what we did in part A, okay. We are going to draw a right triangle, okay. So again, you need to start with the inside of the parentheses here. Okay, we're going to call this theta. So we're going to let theta be the cotangent inverse of negative 15 over 8. Okay, cotangent inverse is returning an angle. That is why I'm calling it theta. Okay. Inverses are tricky to deal with, so we're going to try to get rid of the inverse. Okay, so we know to get rid of the cotangent inverse, we need to take the cotangent of both sides. So this is going to tell me the cotangent of theta is equal to the cotangent of the cotangent inverse of negative 15 over 8. Okay. Then on the right side, cotangent and cotangent inverse cancel. So you're going to be left with the statement that the cotangent of theta is equal to negative 15 over 8. Okay. So from this information, we are going to draw a right triangle of this situation. Okay. So I'm going to go ahead and put my x and y axes on here. Okay, so let me give myself some room. Remember, the range of cotangent is 0 to pi. So I need to leave myself room to work in quadrants 1 and 2. Okay. All right, so here we go. We're going to be drawing a right triangle. So because the range is 0 to pi, like I said, we need to concentrate on quadrants 1 and 2. We actually need to pick between the two. Which quadrant are we in? Okay, well, look at this. The cotangent of theta is a negative value. Okay, in quadrant 1, cotangent is positive. In quadrant 2, it's negative. So the angle needs to be drawn in quadrant 2. Okay, so here we go. I am going to draw my angle in quadrant 2. Okay, I'm going to make a right triangle out of this. Okay, so from the terminal point, I'm going to draw straight down to the x-axis. Here is my right triangle. This is going to be my theta. Okay, so we need to label this. Okay, so this cotangent we know is the x-coordinate over the y-coordinate. Okay, it is the same thing. If you think about tangent, tangent is opposite over adjacent. So cotangent is just the flip of that. So it's the adjacent over the opposite. Okay, so here we go. This is going to be the adjacent over the opposite side. Okay, it does matter where the negative sign goes, whether it goes with the 15 or the 8. That's based on the quadrant. Okay, let's go ahead and label the sides here. If I go straight across from the right angle, this is going to be the hypotenuse. If I go straight across from theta, this is the side opposite it. This other side is the adjacent side. Okay, the opposite side is parallel to the positive y-axis, so the opposite side needs to be positive. So that means the 8 needs to be the positive side, and then the adjacent side lies along the negative x-axis, and so the negative sign needs to be with the 15. Okay, so when we label these sides, the adjacent side needs to be negative 15, and the opposite side needs to be positive 8. So it needs to look like this. Okay. All right. So we need to complete our right triangle. We need to find the value of the hypotenuse. So since this is a right triangle, we call in the Pythagorean theorem. So c squared is equal to a squared plus b squared. We are looking for the hypotenuse, which is c. Okay, so we're going to say c squared is equal to the adjacent side, which is negative 15, that entire quantity squared, plus the opposite side squared. Okay, this is going to give us negative 15 squared is 225, and then we're adding 64. So c squared is going to be, let's go to the calculator here, 225 plus 64. We're going to get 289, and since we're here, the square root of 289 should be 17. Okay, all right, so c squared is 289. We need to take the square root. Okay, since this is a hypotenuse, only the positive value matters. Okay, so the hypotenuse is going to be 17. Okay, our right triangle has been labeled. Okay, all right, so now that we have the right triangle labeled, we can return to the original problem and figure out the answer. Okay, so let me see, where do I have room to do this? I guess I will do this at the bottom. Okay, I'll put it in a different color. So we are trying to compute the secant of the cotangent inverse of negative 15 over 8. Okay, so we're starting over. Okay, now we will apply our work. Okay, so this quantity inside the parentheses here, cotangent of negative 15 over 8, that is what we called theta. Okay, at the very beginning here, we said let theta equal the cotangent inverse of negative 15 over 8. So this is going to translate to be the secant of theta, okay, because what's in green here matches. Theta is the cotangent inverse of negative 15 over 8. So all we need to do now, theta has a right triangle associated with it. We need to go to this right triangle and do the secant. Okay, secant is 1 over the cosine. Okay, you can do 1 over the cosine. Remember, cosine is going to be the adjacent over the hypotenuse, and so if you do the secant, which is 1 over that, that's just going to flip it. This is going to be the hypotenuse over the adjacent. Okay, so this is going to be the hypotenuse over the adjacent. Okay, so that's what we need to go read off of our right triangle here. So if we do that, the hypotenuse is 17. Okay, So we'll put that in. This is going to be 17 over the adjacent side. The adjacent side is negative 15. Okay, this is the answer. Okay, 17 over negative 17/15. Okay, that's it. Done. Okay, so these types of problems look really intimidating. Okay, but they're not bad if you just follow this procedure where you let theta be the interior angle there, and then draw a right triangle that represents it, and then go from there. Okay, now I do recommend checking yourself where you would plug in the calculator negative 17/15 to get the decimal expansion, and then plug in the original quantity and look at its decimal approximation. Make sure you're in radians when you do so. However, I'm not going to do this at this point because we haven't talked about how to plug in inverses to the calculator. It's pretty obvious when you're doing sine inverse and cosine inverse and tangent inverse because there are buttons on your calculator for that. But when you're doing secant inverse and cotangent inverse and cosecant inverse, it's a bit tricky. So we're going to talk about that on the last page of the notes of this note packet. And once you have that information, then you can come back and check yourself.